Welcome, ladies and gentlemen, to Measures of Variability for Ungrouped Data. We're going to work through all of these different measures in terms of the variability when we have data that's ungrouped, and we're going to deal with everything from the range to the variance to the coefficient of variation. So I'm going to roll on through these, so grab yourself a bucket of popcorn and a pencil and a piece of paper if you want, and we're going to get started and have a great time hanging out here in statistics world. Okay, I'm going to work with a set of data that is some companies, grocery stores, drugstores, whatever, and their revenue. So I've got a data set with 8 values in it, and what I want to start out in this first section is to do the range, the IQR or interquartile range, and MAD, or the mean absolute deviation. So let's start with the range. We know that the range is simply the largest value minus the smallest value. So I'm going to go into my data set, and since it's fairly small, which is a good thing, I'm going to look and I'm going to find my largest and my smallest value. Well, my largest value is 66.11, and coming down, my smallest value is 7.87. So the difference between the highest and the lowest point tells us the range or the dispersion of our data set. So how do we calculate that? Just subtract one from the other. So all I did was I took my 66.11, my highest point, minus my lowest point of 7.88, came out with a range of the data of 58.23. Remember, the range is extremely sensitive to these very small values like this. This is almost, these are in millions, so this is almost $10 million below the next smallest value. This one up here with Kroger is a pretty high value, so remember, the range is very sensitive to just 2 data points, and very high and very low. What's a little bit more reliable is the interquartile range, which you'll remember from our measures of central tendency, tends to give us the center of the data set. In order to calculate IQR, remember we have to know 2 things, Q1 and Q3. So let's find Q1, Q3, subtract the 2, and figure out what the IQR of this data set is. Alright, remember from last time that we said that Q1 is the same thing as P25, and we know that little I is simply location, and we would take 25 divided by 100 is 0.25, and I have 8 data points. Remember, 8 is our N, and so what that comes up with is it gives me the location, or at least the beginning of the location of Q1 as the second data point. But remember, when we have 2 data points, right? When we have just 2 data points, we have to go between the second and the third. So let's see what we have there. Alright, so we know that because we have an even value of 2, we have to find Q1 is located between the second and the third point in our data. See how these are organized and have been sorted from smallest to largest? So I'm going to take 17.7 plus 19.86. I'm going to divide them by 2 in order to come up with Q1, which is located halfway between the second and the third term. And that's what this looks like. I'm gone halfway between, it's halfway between the second and the third term, taking my 1727 plus my 1986, divided it by 2, which gives me a value of Q1 of 18.565. I'm going to turn around and do Q3 the exact same way. Alright, remember that Q3 is simply the same thing as P75. So the location I'm looking for is 0.75, or 75 divided by 100, times our n of 8 gives me 6. Again, Q3 is located halfway between the 6th and 7th term. So I'm going to come back up here, and I'm going to go 1, 2, 3, 4, 5, 6, which is halfway between the 43.81, 47.41. So I'm going to add them together, divide them by 2 to come up with the number in the middle. And so now I know that Q3 is located at 45.61. In order to come up with my IQR, remember, IQR is simply Q3 minus Q1. So I'm going to say 45.61 minus 18.565 is going to give me the interquartile range, or the middle of my data set. And in this case, that number is going to be, drum roll please, IQR 27.045. So again, all I did was found Q3, found Q1, took those two values, subtracted them, and now I have an IQR of 27.045. So not too bad, huh? Now let's take a look at doing the mean absolute deviation, which is simply going to be the distance each one of these individual observations falls from the mean, or the average, of the entire distribution. So we're going to calculate the distance, the absolute distance each one of these values falls from the mean of the distribution, in order to determine how much spread there is in our data. All right, remember we said that the formula, because what we're looking for is we want to know how far is each individual x value, remember these revenues are x values, fall from the mean, which is either x bar if we deal with this as a sample, or mu if we deal with it as a population. And because it's the mean, or the average absolute deviation, we're going to divide it by n. Remember, that's how we did a regular average. Remember that since it's an absolute deviation, we're going to take this absolute value of each one of these results, so that we don't end up with a 0. So let's see what our mean ends up being. Alright, so how did I do this? I just simply calculated the mean, which means, sorry for the pun, I added all of these values together, which gave me 264.34. Then I came up with the number of data points, which is n. When I divide the sum of the x by the number of x, I get 334.0425. I'm going to round that off, and for calculating the mean absolute deviation, I'm going to use the value of the mean as 33.04. So I'm now going to go through, I'm going to take each value of x, remember these are x's, I'm going to subtract it from the mean, mu, ooh, that's horrible. Or in this case, I'm terrible at this today, or x bar, right? And I'm going to take the absolute value of that, and because it is the mean, I'm going to add them all together at the end, and let's see what we have. So what I've done while you guys were away is I have simply taken each x and subtracted it from this mean of 33.04, and taken the absolute deviation, absolute values. So I got rid of all of my negatives. 66.11 minus 33.04 gives me 33.07. 47.41 minus 33.04, 14.37. Remember, absolute value. Get rid of those. Just ignore the negative signs. I'm then simply going to take, and once I have done this for all 8 of my data points, I'm going to come up with the sum of the absolute values of x minus the mean. So that is the absolute deviation. This is the absolute deviation. But what I really need to know is the mean absolute deviation. In order to do that, I have to take that 130.69 and divide it by, you guessed it, n, the number of observations I have in my data set. So when I take 130.69 and divide it by 8, my math tells me that the mean absolute deviation for these 8 companies is 16.34. So 16.34, hopefully everybody's math agrees with mine. It's the sum of the distance each individual value falls from the mean added together. So that 130.69 divided by n, which was 8, gives me 16.34 for the value of my mean absolute deviation. So what we now know about our data set is it has a range of 58.23. It has a mean absolute deviation of 16.34, and it has an interquartile range of 27.045. So I will be back with you on the next video with variance and standard deviations. See you then.